Welcome back to another episode of the Office Hours podcast with Professor Brad Perkins. Today in the studio, we have some guests that are here to talk about the relatively new major in the College of Engineering, the environmental engineering major. And we have one of the founders with us to talk. Why don't you go ahead and introduce yourself and who you brought with you?
Okay, my name is Dr. Kaoru Ikuma. I'm an associate professor in our department, Civil Construction and Environmental Engineering. So I was one of the founding members of the Environmental Engineering major, which started in fall 2020. And it's not because of this, but if you had noticed before 2020, our department name was Civil Construction and Environmental Engineering, but we had 2 degrees. Civil engineering and construction engineering. So to even it out, to make our department name true, and that's not actually the reason.
I was going to say, that's the whole reason?
No.
That's the whole reason we started a new major, is just to balance?
Well, hey, it's important.
It's important.
But,
all right.
So one of the reasons was because, so we used to have we still have a civil engineering major with an environmental emphasis. And we were, for years, saying that that's not enough to train and educate and prepare our students for an environmental engineering career, which is really critically important for society. And one of the drivers was that University of Iowa started a program a couple of years before us.
Ooh, and we can't be second fiddle to those Hawkeyes in anything.
Well, especially in engineering, right?
Especially in engineering. Do they even have engineering at University of Iowa?
They do.
Oh, well, they claim
Yeah,
they do.
I'm trying to be politically correct here.
Well, do they really? I don't know.
Well,
right?
So ironically, their environmental engineering was stronger than ours for the longest time, research-wise.
Well, that's just embarrassing.
Research.
Okay.
Well, it's
Okay.
changed. Times are changing.
Times are changing.
Hey,
okay.
I'm working hard. Okay.
Okay.
But anyway, so when they started that process, we were talking with them, and we agreed that one university preparing Iowans to become environmental engineers is just not enough. There's way more demand.
Yeah.
Than we can supply. So it made sense for both of our universities to have that degree.
Okay.
So that was one of the primary reasons why we went forward with an environmental engineering degree.
Okay. All right. Oh, that's an interesting background.
Yeah.
Right. And personally, I think that is a fine reason, because we can do it better than the Hawkeyes.
And,
that is a perfect reason.
And I will say that I do think we do. We already do.
No, we do. We do. We
Okay.
do. Okay.
All right, we do.
All right. Okay. So who'd you bring with you?
So I brought 3 seniors. They're all graduating seniors in environmental engineering. They are particularly team leads of a recent experience we had at a national design competition where they won several awards. So I wanted to bring them and basically have you hear what they have to say.
Oh, okay. All right. That'd be awesome. Here, go ahead and introduce yourself there. Make sure you get close to the mic.
Hi, I'm Jack Edwards. I'm, like Dr. Kuma said, a senior graduating in environmental engineering. Then after graduation, I'm going to be doing water resources design at JEO Consulting.
Here in?
Down in Ankeny.
In Ankeny. Okay.
I'll also
okay.
be living here, though.
All right. Oh,
here.
still. Okay. So you're not going far.
No.
All right. Okay. So here, we'll go and we'll just have let's introduce everyone, and then we'll kind of come back and get into the background. Go ahead.
Okay, hi, my name is Hally Michaelis. I'm also a senior in environmental engineering, and after graduation, I'll be moving to Oak Brook, Illinois to work for Rue Associates.
Oak Brook, Illinois is part of Chicago?
No.
Oh, I thought the entire state was just part of Chicago.
Yeah. But it's depending on traffic, it could be like 20 minutes to an hour away from Chicago.
Oh, it's Chicago then. I mean, it's Chicago. It is.
Okay.
It is. Okay. All right. For the purposes of Iowans, that's Chicago. All right, go ahead.
Hi, my name is Caitlin Agabin. I'm a graduating senior, and after I graduate, I'm going to move up to Minnesota to work for Brown and Caldwell.
Okay, doing what?
Designing water and wastewater treatment plants.
Okay, all right. So, we have a captive audience of students that are just now. Hold on. When did we start the major? Right? When was Like, because there haven't been too many graduating classes of
Right.
true environmental engineers, right?
Right. So fall 2020. So
Right.
we've had graduates.
Great timing. That is absolutely the time to
It
start
was
anything
tough.
new. Fall 2020.
I mean, imagine
Good
doing
thinking.
learning community that
Oh, gosh.
semester. Oh my goodness.
Oh,
Anyway,
don't even get me started on trying to do classes. Like, imagine doing
But we
labs.
survived. We
right?
survived. We survived.
Yeah,
so
we didn't do it.
had a bunch of civil engineering students who switched over. So we have graduated, but this will be the 5th class. But
Oh, okay.
we have
okay,
our
okay.
full class that entered their freshman years as environmental engineers. This is the 2nd cohort that we're graduating.
And then did all of you start as environmental engineers? Yes. Okay. So here, podcast can't hear you nod. Okay. So you all started as freshmen?
Yeah, I did. Yep.
Okay. Yes.
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 Okay. Well, how'd you? So with this, okay. So you're starting as freshmen. This is 2025. Were you coming here in 2020 then, or 2021 as freshmen?
2021.
Okay. So my question would be, how did you find a brand new major as a freshman? I mean, let's be honest. A lot of freshmen in engineering are doing good to find the west side of campus. You know, no, I know. You know what I'm saying is it's a monstrously huge campus.
Mm-hmm.
You're just new there. What do you want to do as your major? I was good at math, so people told me to be an engineer. You know, and then somehow you have to find across this campus. You have to find environmental engineering. How did that happen? Does anybody want to tell me how that ended up happening? Anyone? Who's got the?
You guys want to start?
Yeah, go ahead.
I can go.
Go ahead. Yeah.
Well, when I was graduating high school, I had no idea what I wanted to do with my life.
Well, you're
I-
not supposed to at high school.
Yeah,
you know?
and still don't really.
Right? That's fine. That's totally
but
fine.
yeah, there's time.
Yeah, there is. You're in your 20s. I mean, come on now.
But I knew I cared about the environment, sustainability, wanted
Okay.
to help people do impactful work. And my oldest sister is actually an engineer. She's architectural, which not the same, but I really look
Not
up
the
to
same,
her.
but that's okay. Well, not even here. So where's she going to school at?
She went to Missouri S&T.
Okay.
Yeah,
All right.
she's been graduated for a lot of years. But
Well, okay.
anyways,
So she's saying you should be an engineer.
no,
No.
not necessarily.
Oh, okay.
But I just looked up to her a lot, and I was like, well, if she can do engineering, so can I. And then I
point.
found environmental. My dad actually was helping me do a lot of research on like my options, and he actually found Iowa State with environmental.
Oh, okay.
And I was like, well,
And
it's-
he's like, and it's cheaper than University of Illinois.
yeah,
Yeah. So Dad's like, yeah.
yeah, and it's
Good
only
call.
like 3 hours away from home, so it just
Okay.
worked out. Yeah.
All right. So you started as a freshman, and you're like, okay, this is what I want to do, and you didn't switch majors
No,
all the way through.
no.
That makes you kind of rare for a student, though. You know, because I think that's fair to say, most switch majors at some point. Okay, so you're like, all right, you started and then what? You started in like learning community with Kaoru?
Yeah.
Okay, all right, all right, all right, fair enough then. And then along the way, did you get internships?
Yeah, I interned 2 summers with the Army Corps of Engineers in
Okay.
Rock Island, Illinois.
Okay,
Yeah.
all right, and then did that kind of cement you're like, this is kind of interesting?
Well,
Or did it cement, no, I don't want to work for the Corps of Engineers?
no, I did enjoy working for the Corps. My first summer, I worked in the geotechnical engineering section and
Okay.
realized that's not what I want to do.
Oh, well,
So-
yeah, everybody realizes that, right? I mean, you know,
Well, no, somebody's got to do it, but
somebody's got to do it.
just not me.
Just,
Okay, Hally, I love that answer.
yeah. She's going to probably make that her, like, signature line. Geotechnical. Somebody's
Someone's
got to
gonna
do it,
not us.
but not me. Right? That could be the whole motto of
Turn it into a
environmental-
sticker or something.
Yeah, that's a good one. I like that.
Just don't tell our colleagues.
Don't tell our colleagues. It'll just be between us.
Okay, good.
They don't watch my podcast anyway. So.
I will seriously get in trouble.
You will seriously. Yes, and for the record, I did not tell any of them to do that. You should direct all anger and correspondence towards Dr. Kaoru at Iowa State CC.
Hey. And I'm going to jump in and say that, yes, students tend to, change majors.
Yes.
I will say, because I teach learning community the first semester that they come in, and then I also go all the way through the senior year classes. Of our environmental engineers that start as environmental engineers, we usually retain about 80%, if not more.
I think Connie is probably about the same
right?
too.
Right. So it's not too bad.
And I think that getting faculty involved early in the learning community is a huge help.
It really helps. Yeah.
Like Jenny Baker's doing our learning community, and she's fabulous at it. I just had her on this podcast. We only taped it like a week or two ago. And I've known Jenny since we were in the consulting world like 20 plus years ago. So she's really good at that, and I think that helps so much. Because, it's a different environment than it was when I was a student. There was no learning community, advising was like, probably 80% of you are going to fail out or change your major anyway. So, it's going to be rough. That was Engineering 101 pep talk. That was lovely.
Times have changed in a good way.
Yes, they have.
At least
they have.
I want to be able to say that.
Yeah, no, they have. They have changed in a good way because we do a lot more with getting students involved earlier in engineering. I think we do a lot better job of getting students internships that keep them connected to, the major. I think that's a good thing. So it's good that you found something you're interested in. I think that's awesome. You found the right fit, and you just kind of progress from there. And now you're graduating and what you started out as. That's pretty awesome. Okay. So so how'd you get involved in? Did you have a sister that told you to be an engineer?
No, I'm the oldest.
Aha! So you're the trailblazer. Okay.
Yes.
Are you from Minnesota? Are you from Iowa? Where are you from?
I'm from Illinois.
From Illinois as well. Okay. All right. So someone else that said, tuition's cheaper over there.
Yes.
Yes. You know what? I bet you sometimes, some semesters, I probably have a third of our students from Illinois. I don't know. Is that the same in civil and environmental?
I think so. I think there's a lot of students that I meet that also say that they're from the Chicagoland area.
Oh yeah, Chicagoland. I've heard. Yeah, that's
I would
why.
say, probably at least a quarter every year.
Yeah, at least a quarter. But sometimes, you think it was a third. All right, so you're like, okay, how did you hear about us at Iowa State, environmental specifically?
So I knew that I wanted to do engineering. And I knew I didn't want to do any software computer engineering because that's what my parents do.
Oh, okay.
Didn't want to do.
Okay, you want to do something different?
Yes, and a close family friend of ours, their son went to Iowa State for aerospace engineering.
Okay.
And he's a year older than me, so as I started looking for colleges, they kind of recommended looking into Iowa State because they have a really good engineering program. And then from there, they were advertising their new environmental engineering major, which was very intriguing to me. So.
Okay. All right. So you're like, so did you come here for a visit or anything, or did you just like?
Yes, I did. My cousin is also a graduate from Iowa State in software engineering, so she gave me her own little tour of campus.
Okay. All right. So yeah, you were Kaoru.
So not to embarrass you, Caitlin, but their entering year 2021, we had 2020 and 2021 were both tricky, right? Like
no, they were disasters.
Yeah,
they're like dumpster fires on campus.
In their learning community, I think we lost probably 30% or so.
Yeah.
And a bunch of them, I don't remember I want to say biosystems, but I'm not sure. Maybe biosystems engineering, which is fine. It always happens. But I remember in learning community, Caitlin, that you came up to me and basically was like, so can we talk about what environmental engineering is? Because I'm getting, confused with all my friends thinking about changing majors. And we talked about how, it is about the human side and cleaning up after ourselves. And it's really about the infrastructure that we take care of. And that's when you were like, good, because that's what I want to do. So you had that conviction very early on.
Yes.
And I really distinctly remember that.
Well, that's interesting because most, I would say, like if you hate to generalize, but let me generalize just a shade, is that most at age 18 are like, you're doing really good to wake up in the morning and get dressed and you know what I'm saying. Picking something out of engineering so specific seems interesting to me because in Connie, the ones that start as a Connie are usually people that have a connection with construction.
Mm-hmm.
You know what I'm saying?
Yeah, right. Parents
And then we get most of our graduates came in from other majors,
right.
Or they were undecided, like truly undecided. And undecided Iowa State usually means they put you in mechanical engineering.
Right.
I mean, come on, you have to have had friends that are like, yeah, I want to be an engineer. What type? I don't know. Oh, mechanical. I mean, that's true, right? So coming into environmental is just very specific, and that's what's interesting.
So when I ask students coming into learning community, why did you choose environmental engineering? It's really, dare I say, cute.
Dare I say? Well, you said it, not me. So you,
yes,
okay.
Yes. We're not supposed to call them kids, right?
Right.
Anyway, they tend.
It's okay.
They tend to say they want to save the planet, or help the planet. And
Okay.
do all those. And I'm like, that's great.
Yeah, we don't
that's
get
great.
those in Connie. I don't know.
But that's a very broad vision. And
Yes, it is.
That doesn't necessarily
That's
tie
true.
into engineering. So that's where the students tend to start questioning whether engineering is for them and environmental engineering is for them. But
Okay.
many of them do realize, oh, this is my way of doing that through environmental engineering.
Of both, right? In other words, a profession that actually leads to a paycheck. But also helps with society's greater problems. Right. Okay, I mean, is that kind of like too broad brush for kind of how you were as a freshman, or do you think that's fairly spot on? Or this guy's like, no, I just wanted the paycheck. I heard there was steady work in it.
I mean, it's part of it, but it's
a part of it.
It's not the main part,
Okay. Well, okay. So how did you get into it then?
Well, junior year of high school, I was so convinced I was going to be a forensic scientist.
Okay.
So
that is different.
That was my plan.
Okay.
And then I got little bird on the shoulder. My dad.
Yeah.
Tell me not to do that.
Okay. Why was that? Why was that?
Because he's an engineer, and he was like you have to be an engineer too.
You have to be an engineer too.
And
Okay.
Then when I was doing college tours, I was convinced I was going to be a chemical engineer. Thank God I didn't do that.
Oh yeah,
that
brutal.
Terrible.
Yeah.
And then eventually, I knew I wanted to work on nature-related projects and environmentally related projects.
Okay.
And I figured out Iowa State had an environmental degree.
Okay.
I actually really didn't know exactly what it entailed, to be quite honest.
All right.
So in learning community, when it's like, oh, here's wastewater and air quality, I'm like, oh, that's cool, I guess. But,
Cool, I guess.
But you stick it out, and then I ended up actually really enjoying it. And I didn't switch.
Okay. All right.
That's kind of my trajectory here.
Okay. All right. Well, those are interesting trajectories, So just starting, finding it, and getting there because, so if prior to 2000, it was just an emphasis, right?
No, 2010, 2020, yeah.
You got it. There we go.
Yes.
There we are.
Prior to 2020, yes.
Prior to 2020, it was just an emphasis. Okay, so how did you get, if you don't mind, if we go down kind of, so we've heard from the students, however, your path here is a little longer.
And very different.
And very different. And that's what I would like to hear about. You want to talk about that one?
Yeah, so I'm actually technically not an engineer.
What do you mean you're not an engineer?
I know, I'm not supposed to say that. A lot of people are scold me when I say that.
What?
So my undergraduate degrees are not in engineering.
So you're not an engineer.
Yeah,
okay.
right. In that way, I'm not
an
engineer. So I did my degrees at Virginia Tech in biology and biochemistry.
Okay.
And then basically I had that epiphany moment in my third year when I took microbiology. And then I took environmental microbiology. And that just led me here because environmental microbiology is all about understanding how microbes work in the environment, but also what you can do with them to clean up the environment.
Okay.
So a lot of the work that's being done in that field is in environmental engineering. So I but I did my master's in environmental engineering.
Oh, but
because
you
of that.
have an engineering
Yes,
degree.
yes. And then
Okay, so you are
yeah.
an engineer. I'm going to take that back,
And then
right?
my
Okay,
PhD in environmental engineering as
okay,
well. So-
okay. So no, that's you.
And I
you're-
never
you're in
really-
the club. You're in the club. It's fine.
and I
It's
never
fine.
looked back. So-
Okay.
And I really enjoyed
And that was at Virginia Tech,
so yeah, bachelor's and master's at Virginia Tech, and then Duke for my PhD.
Duke for your PhD.
Yeah.
Okay, so what was your PhD subject?
So environmental engineering still. I was looking at using microbes to remediate remediate environmental pollution, basically.
Okay.
Try to clean it up.
All right. Microbes as cleaners.
Yeah.
Oh yeah.
They're great.
Makes
They're-
no,
they're-
it makes
yeah.
perfect sense.
Yeah, you don't have to put in energy; they'll do it all for you.
Right. Well. Essentially, what you're talking about is a septic tank on a bigger scale.
Exactly. A little bit more controlled and a
Yeah,
little bit
well,
more,
Yeah, a little bit more to it.
There's a lot
little bit-
more to it, but
I may
I'll
have-
let that happen.
I may have-
that slide.
I may have glossed over a few important details.
But then, generally, I really environmental engineering as a field is right for me because
Yeah.
not only
Well,
because
with that
of,
chemistry background. I mean,
right, but not only because of the technical stuff, but also because it is the backbone of society. Like modern society relies on flush toilets. Or,
yes, it does. See, now-
tap water and all those things we do that in the background.
Well,
and
see,
that's just
you are
fascinating.
Well, you are preaching to the choir there because, in one of the classes that I teach on mechanical design, we do the normal stuff, heating, cooling, right? But like a third of the class is on water.
Yeah.
And water for plumbing. Now, more on the consumption side,
Right.
obviously, not on the cleaning it up side.
And it's fascinating because, water for plumbing is not regulated the same way, right? Like that's more on the
Consumption side.
Yeah, consumption side and the building side.
Yes.
Treatment of that water is on our end,
Yes.
right? And there's that. I always find it really interesting that there's a disconnect between those two. We never actually talk.
No,
when
never.
we should be talking.
Never.
right?
No, you are exactly right. Here, one of the biggest things that I talk about in that class is we talk about energy and we talk about water and the scarcity of both.
Yeah, right.
And how my personal opinion is that, and none of you take my classes, so you wouldn't have heard this, but my personal opinion is the issue of energy and water are going to be the seminal, like fundamental issues of their careers.
Yes.
All right. Now, in Iowa, do we care about water conservation?
We should.
Right. You know what she said? She's like, we should. Right. What she means is, no, we don't. Right. Not really. And here's why: is that water here is plentiful. It is clean. It is cheaply and easily moved around, and we don't have scarcity.
But there are cities that are really struggling with drought.
Yes.
They are running out of water.
Thank you. I was about to say.
Okay.
All right. Now, a lot of our students,
Not that you gave me any notes.
Not that right. But that was a great lead in.
There
Thank
you
you.
go.
Okay. Well, and the reason you didn't have to be prompted on that is because it is just facts.
Yeah.
The entire southwestern part of the United States is running out of water. There's no silver bullet for this problem. There's no magical fix. There's not anything that some computer genius is going to cook up AI isn't going to solve this until we can clean water quickly and easily without energy,
Right.
which is not a thing
Right.
currently
It's
with
not.
current technology. All right. I mean, I'm just going to caveat that. So one of the things that we talk about is the Southwest. All right. As students, did you know that every drop of water west of the Continental Divide is regulated? Every drop. Like, for example, if you had a house in Colorado and you want to put a rain barrel at the end of your downspout off your house, that if you don't have the right permits, you can't do it. Did you know that?
Did not know that.
You did not know that? Did you guys?
No, I did not know
No.
that.
Yeah, it's already spoken for. Other people have rights to it. You can't collect it until you have the appropriate water permits for it.
Well, the water rights like out west are a lot more stringent, or like they should have water rights.
Yes.
Whereas,
Yes.
like,
No. That is it. And and by what I'm saying is let's say you have a stream going by through your land, you can't just dam it.
Mhm.
You might not even be able to use it. Can't use it to water your lawn. Can't use it. I mean, without the appropriate permits. And so what I'm saying is every drop of it is regulated, and the problem is that there is not enough of it. Do any of you know much about? We talk in my class about Hoover Dam, Lake Powell. Do you know much about Lake Powell? You're all looking at me like
is that the one behind
the Hoover
the
Dam.
dam? Yeah.
Yes.
How it's dropped
How it's dropped.
tremendously.
Well, it's gone all over the place.
Yeah.
You know, it's water. They've had a really couple of good years of rain, but they were literally at crisis levels. And by crisis levels, what I'm talking about is the water level in Lake Powell was approaching the point at which they'd have to start turning down the turbine engines in Hoover Dam that create electricity, which is a big deal because something like 10 million people get their power from that. However, the bigger deal is that something like 20 to 30 million people get their water from the downstream of that dam. What happens when the city of Phoenix runs out of water? It's a real question. They're struggling with it right now. You know, I mean, the whole Southwest is struggling with this question, and it hasn't just been the Southwest. If we go back a few years, you remember the big Texas drought, right? Which city was it? Was it? I want to say San Antonio was within a month of running out of water at some point. You guys are looking at me like
Not
this can't
sure.
be a real thing, can it? What's that?
I believe it's a real thing. I hadn't heard of that particular example.
Well, it's. Yeah.
But I think what's crazy is that, you know, in a water-rich state like Iowa,
Yeah.
you have cities that are actually saying the same thing. They are running out of water. They will be out of water in 2 years.
Who? Wait. Oh, I haven't heard this.
I'm not
Talk to me about
sure
this.
I'm not sure if I'm supposed to share the.
Oh,
city
okay.
name.
Maybe this isn't
So-
something to share because I have not heard
Well,
this.
so I've gone to a couple cities and talked to their municipal utilities folks, and
Yeah.
basically a lot of these places, you know, get their drinking water from groundwater, and the aquifers
are being depleted.
are being depleted. So it's not because of residential use, but because of certain types of industries, and so, you know, they want the economic, you know, positive from having those industries there,
Right.
but they're using a lot of their water, and people are running out. So seriously, they are going to run out by their projection within 2 or 3 years.
That's fascinating to me.
So we're trying to help them come up with, you know, different ways of getting around that.
Well, this is like I said, and energy and water are, in my opinion, the same thing,
Right.
the same subject. We don't have enough electricity. We just don't. We just don't. You know, we can't generate enough. Our data centers and AI has an ever-loving thirst and demand for energy that is under current technology almost insatiable. Right?
And a lot of them are in Iowa.
And a lot of them are in Iowa.
Yep.
You know why? You know why they're in
Yeah,
Iowa?
right.
Right? Because electricity is cheap here.
Yeah.
Comparatively.
And supposedly water is abundant.
And
correct?
water
So-
is abundant.
right,
Okay. Well, but what happens when that's not the case anymore?
which is
Which is now, when we say, okay, there's a couple cities, you know, running out of water. As students, you have to understand there's a whole lot of assumptions that go into that. With current harvesting mechanisms that they have, with wells at current depths.
Right.
See, there's answers to all of those. It's just that they're engineering and they're expensive. Here, Las Vegas, same thing. Have any of you? Well, if you're not familiar with the issues at Lake Powell, city of Las Vegas, when water levels at Lake Powell were getting low enough, there was fear that the intake from Lake Powell that fed Las Vegas, which is only about 20 to 30 miles away from Lake Powell, they pump it from the lake over to Las Vegas. And Las Vegas was like, hey, it's getting pretty desperate here. Las Vegas already reuses, what is it, something like 90% of their water?
I actually don't know the percentage, but yeah.
It's really high. It's really high. I think they have the highest percentage of any city in the United States. But anyway, they're like, we need what they called the third straw, the third pipe going into Lake Powell, but it had to be lower. They spent almost $1 billion tunneling a pipe from Las Vegas to Lake Powell to get lower, to get into the water level. $1 billion. Students, what do you think about that? What does that mean? It's an open question. Caitlin, you got a thought? Hit me with it, Caitlin. You're a senior in engineering. Give me a brilliant engineering analysis of a city spending $1 billion on a pipe.
That's a lot of money that the city has to raise, and it's a lot on, I'm assuming they're going to take it from their residents to help pay for the
Oh, yeah, taxes. Yeah, all right.
pay for the pipe that they just put in the ground. So, yeah.
And this is the point that I want to make, is that for any city, and I know it's Las Vegas and they throw money around like crazy, okay, but they're dependent upon tourism. Las Vegas doesn't exist. Here, Las Vegas and to some extent Phoenix are testimonies to engineering, in my opinion, because they could not exist unless engineering forces the answer to it. In other words, there's not enough water. It's too hot for humans to survive. You know, just look at Phoenix. Have you ever been to Phoenix, any of you? Yes? Yes?
Yeah.
Right? What time of year?
I went over spring break.
Oh, okay. Not terribly hot yet.
Not yet.
Not yet, but by not hot, what was it, 90?
No, like 80s, 70s,
Oh,
80s.
oh, beautiful
So,
for
yeah,
Phoenix,
very
right? I've been there in August, and it's like you don't go outside.
Mm-mm.
You know, you don't see anyone. It's weird. You drive around, and you don't see a single human outside just walking. You know, no dogs, no humans, no nothing, because the dogs will burn their feet.
Yeah.
You know, they make boots for taking your dog for a walk in the middle of the day so that they don't literally melt to the pavement. But my point is, neither of those places exist if we didn't force it through water management and energy management. All right? So back to the $1 billion, they're not spending that unless it's a crisis. And that's exactly what they had, is that we don't have enough water where we're using about as much as we can reasonably do. So my point is that seems crazy, doing $1 billion water program, and yet it was so necessary that it was done anyway. Well, that's kind of like what is to come, right, Kaoru? I mean, if you're talking about cities running out of water, there's going to be similar things happen, where cities are going to have to make some tough decisions. It's like, do we clean the wastewater and reuse?
Right.
Do we drill for new? But is that really just a temporary thing, just drilling down deeper? Because
Keep
what
going.
happens?
Yeah, right.
Because then the neighboring city has to go down deeper, and the neighboring city has to go down deeper, and then we're drawing the aquifers down, and at some point, you know, I don't know the answer. I mean, I don't think anybody knows the answer to this.
We don't. We really don't. And you know, okay, so consumption should be conserved, of course, but that change in people's mindset and lifestyle is so hard to make. I mean, realistically, that's what we should be doing. Right?
Yes, it is.
So
well, and that's why I teach it.
Yeah,
is that systems that maybe don't make sense in Iowa economically, like rainwater harvesting, gray water harvesting, you know, and I'm sure as environmental engineers, are you familiar with both of those terms? Rainwater harvesting and gray water harvesting, and how they're different?
I'm not familiar with gray water harvesting.
Okay. Well, that actually makes sense because you're dealing with things outside of the building. Gray water is dealing with things inside of the building, like a mechanical, you know, like someone doing the mechanical design for a building. So what that is that we take the outlet from like hand washing sinks, showers, dishwashers, stuff like that. We take that water, and instead of sending it to the wastewater treatment plant, now maybe we use it to flush a toilet with, because it's fine for flushing a toilet. This has always fascinated me. Why do we spend all this money and energy cleaning water, and the vast majority of it goes to toilet flushing?
right. And
Do
that's
you
the irony.
know the answer to this?
I don't.
Right?
It's the irony, right?
Right,
Absolute
the irony? Okay,
Well,
see,
so-
this is where the outside doesn't talk to the inside people.
Right, but so if you think about it,
Mm-hmm.
of all the public water supply that is treated,
Yeah.
you know, if we start looking at that and looking at the how like what part of that pie goes
Yes.
where, it's fascinating to see that people consumption in even buildings or by people is still a small percent. So of that small
Well,
percent, right, a lot of it is going to things that aren't really about people drinking or needing clean water.
Oh, the vast, actually, what is it? Hold on. Oh, I should know this number. I apologize for not knowing this number. But something like, it's over half goes to flushing toilets.
Right, and it's gotten better, right, with the
Low flow
low-flow
toilets and
toilets.
that type of thing.
So that's getting better, but
Getting better, but it's still over half.
yeah.
I
So
mean-
so it's fascinating because I actually grew up in Japan,
Mm-hmm.
and Japan is a tiny country surrounded by seawater, right?
Surrounded by seawater,
So-
lots of water, you can't drink it.
Exactly. So our whole culture is based upon conservation.
Right.
Like you need to think about what you're using and how much, and make sure to not use it too much. So in a household of 5, for example, you would only have 1 toilet. Here,
Yeah.
right, the norm is to have 3,
3.
if not more,
Multiple
toilets,
showers.
right? So
Yeah.
so-
probably
so
2
the-
or 3 showers.
so the whole the way the lifestyle
Yes.
and the whole expectations are very
Very
different.
different.
And
very,
that
very
that's
different.
very difficult to break down, I think. But if
Oh,
we
it is.
can, it'll help a lot.
Well, you know how it's going to, you know the way it's going to eventually have to happen, right? You don't know?
But
Come on, you have to know. Can't be cheap anymore.
I see. So yeah,
Yeah.
and we talk about the price of water being way too cheap, right?
Yes, yeah, well-
Subsidized heavily.
Heavily subsidized. Yeah, because once
And
you
energy
remove,
too,
and
so.
it doesn't matter once you remove the true cost of something from the users of something. No matter how well intentioned it is, you separate cost from consumption. Now you get consumption without any regards for the cost.
Right.
Let's look at what is it, San Bernardino, California, and their desalination plant.
Yeah.
Okay, so
Insanely expensive.
so by expensive, what she's saying is San Bernardino, they build a desalination plant because things were getting to catastrophic levels in California. Where are we thinking, like 2017?
Yeah, sounds about right.
Yeah, from like 2017 to 2020. I mean, it was terrible in California. I mean, they were in the middle of a drought of epic proportions. They turned on their desalination plant that they had built. The tap water was as expensive as bottled water. Think about that for a second. How would that change your behavior,
Yeah, right.
right?
Yeah, definitely try to use less.
Use less. Well, just think about your daily habits. You know, it's like, okay, I mean, now with this hair, I can, I don't have to spend much time in the shower with this. I can take a wet rag, just, I'm like good, but
Yeah, I take really long showers.
what if you had to buy bottled water to shower and wash your hair with? That's what
Yeah.
That's what the people that is essentially what that desalination plant was doing cost wise. Now think about it. You're like, well, how many bottles of water do you need? How much are you spending on said bottles of water? The point being is that extremities. The only way to truly change behavior, if we could put all the public service announcements that we wanted about, hey, save water, and you're like, oh, okay, that's nice, but to get real change, now you're like, ooh, I could either go out to eat or wash my hair.
Right. So another fascinating thing, right? Like when I was a kid, so in Japan we had a big earthquake,
Right.
and
Oh, the tsunami, the one in.
no,
Oh.
I'm much older than that.
That's true. I'm sorry.
It's
sorry. I
the
was
big
there.
earthquake that happened around the Kobe area
Okay.
in '95.
95. Okay. All right.
I won't tell you how old I was, but anyway, I
You're
distinctly.
younger than me. So,
I know. Yes, I'm the younger one.
Yeah.
But I distinctly remember we were out of running water for 2 months. 2 months.
Yeah.
Electricity came back actually pretty quickly.
Yeah.
But water and gas, nothing for 2 months. So
Ooh.
this is, not even like buying bottled water because none of the infrastructure, it
Yeah,
was
there's
all
not-
crumbled.
yeah.
Right? People were coming in with water trucks to help, but
Yeah.
you basically had to lug all
had to
these
carry your
drugs.
water.
Yeah, and then
Did
really
you-
ration it. So it was, thankfully it was in the winter. so it was
Right.
like, okay, maybe we'll take a bath once a week kind of thing.
Yeah.
And that can be the reality, and that really, really gives you that reality check of how are we using water? How are we? We're taking so much for granted, in a way that is destroying our own lifestyles. So,
It is. It is. We are literally kicking these problems down the road, right? But, people my age are kicking down the road for them to solve. Sorry, I hate to tell you this, but that's the way life is.
No, it's true.
No, it is.
think-
It is.
I
It
think
is.
the question
a
also
little
has
closer.
to be,
A little closer.
I think the question also has to be asked, like in the Sanborn and Dino, scenario.
Yeah.
Like it's the same price, but also are people gonna change their lifestyles over a couple more dollars? Per gallon?
It's not a couple more. It's not.
Or
Dude, it's
even if it's
not just a couple more
five,
bucks.
like 5 times more expensive.
Yes.
Let's say about.
Well, yes. Here now, hold on. What else is expensive in California?
Gas,
And
groceries, everything.
yes.
Everything.
No, what I'm saying is that if you're living in a situation where maybe the high price of rent and gas and groceries and all these things already have you pretty tapped out. What if there just isn't enough money for said increase? What could you withstand a tripling of in 1 year? All right, as a student, for example, what if you know what, Kaoru, we could build a much better town engineering if we tripled their tuition. I mean, that sounds fair to me, because I've already got my degrees and you've already got your degrees. So what do you guys say? Triple your tuition? We could do a lot of good things with triple tuition. Make it more.
No, thank you.
No,
Maybe you can take all the lab fees that
what's that?
classes randomly
Classes
apply
randomly apply?
that
Right.
go to
to
Oh, well,
wherever.
yeah, we're
That-
tripling those too.
well, and that go to a black box that we don't know where.
Yeah, where does that go?
I at
Anyway,
least-
I
I
didn't
don't
say
know.
that. She didn't say it. These are just theoretical questions that you ask. Okay, but the point is that you're like, whoa, triple tuition. I know. Let's just bring our tuition up to the same level as Illinois. Who's in favor? Yeah. They're like, wait a minute, that's not funny. That's not funny. That seems reasonable. Doesn't it seem reasonable to you? Seems reasonable to me. No.
No.
No. Why not? Why not?
It's what, double the price?
Something
Almost?
along those lines, yeah.
I'm not sure what Illinois is, but
Yeah. Right. In other words, that would have changed your behavior. You're here in Iowa taking school because Illinois is so expensive. You're saying, yeah, I know other people pay the tuition, but I've found an alternative and I'm going to go do something different. And it fundamentally, think about how much that changed your behavior. You switched states, which led to different degrees, which led to different experiences, different friends, different jobs. Your whole life would be different if you were looking at tuition and you said, if Iowa State's was on par with Illinois or even higher, you'd have been in Illinois or somewhere else. Maybe you're talking to your sister about going to college in Missouri, which I don't know if I would ever recommend, but anyway.
oh,
I grew up next to Missouri, so it's okay. I can make fun of them.
I don't know if she would recommend it either.
Exactly.
good thing I didn't go there. Then I toured there,
You toured there. Okay.
and their tuition is crazy.
Yeah.
Yeah.
I think Mizzou is like $47,000 a year.
Seriously, from a zoo?
Mm-hmm.
Exactly.
I think we're selling ourselves short
But
here at Iowa State.
okay, after this, people are going to listen to this and they're going to like, you know what? We are raising their tuition. These guys are like, yeah, next year. They're like, yeah, rock on, raise that next year. So, but here's my point: is that yes, I do believe people will make different decisions once cost-wise they're paying it. And be clear, I am not saying, oh, let's just make everything more expensive. I'm absolutely opposed to that. I mean, I mean, the problem that California has is that things are getting so expensive. People are just decided, you know what, it's not worth it. The reason Phoenix is growing and California is shrinking, they're like, where can I go that I don't have to move too far away from, but yet things are cheaper and I get more freedom? Oh wait, Phoenix, which makes Phoenix one of the fastest growing areas in the country. I don't know if that's true this year, but it has been for some years past. So, however, Phoenix needs more water, needs more electricity. How do we get those things? Well, I hope all of you are good at your jobs, because that's what's going to be needed. Is that we need solutions that people can afford. I mean, the math on how to make water clean is pretty simple, right? As a mechanical engineer, I'm like, okay, we need energy. Let's turn it all into steam, leaves behind all the junk, pure water. Awesome. Problem solved, except what? Come on now, seniors in engineering, what's the problem?
Energy.
Energy. And energy is?
Expensive.
Expensive, especially in California. All right. So electricity wise, let's say that here in Ames, maybe we're paying what, 15 cents a kilowatt hour ish, somewhere around there. All right. San Bernardino, California is probably double that, if not more. Okay. So I mean, it's a little more complicated than that, but let's just say it's about double. All right. And do they have an excess of energy in Southern California?
No.
No. What's their problem? Anyone know? Their problem is that they don't have enough generation capacity, and they import a lot of their electricity from out of state, which means long transmission lines, which means losses along the way, which means that you're getting, they're buying a certain amount, but getting a fraction of it, so the cost per kilowatt hour for the residents goes up. Energy and clean water are the same thing. So my personal opinion is the solutions that we need are things like conservation as much as you can. And here, there should always be a two-part discussion on energy and water. Conservation and production. And what you were alluding to earlier is absolutely true. We have separated those completely. All right? I'm in the consumption side of things.
Right.
Okay? You're going into the production side of things, and we got to get serious, or more serious, I think, about both.
And water and energy already are separated in the production side too.
Yes,
So
well, they are.
Yeah, right.
They are. Well, not always. When I was at
Yes.
Black & Veatch, I designed a cogeneration plant for
Right.
the Kingdom of Bahrain.
But
I
you
mean,
don't-
I designed a small part of it, like tiny part of it. I said that like, oh yeah, it was my design. No, it wasn't.
But that's few and far between.
It is.
Yeah.
It is few and far between because
Right.
would California even let you build a coal-fired power plant
Right.
on the ocean?
Right.
No, that's not happening.
But so when we teach about drinking water treatment or
Yeah.
wastewater treatment, we tend to just ignore the energy side, or we talk about it, but
Right.
we don't actually have students compute that or calculate that and realize what
Yeah.
that looks like. And that's just the traditional way of doing it.
Yes, of course it is, because that's someone else's discipline.
Right.
Right?
Which
That's
is
someone else's-
which is a big
And we all
problem.
do this. Well, okay, but this is a byproduct, I think, of a lot of things in engineering. Is that because of liability, because of experience, because of knowledge level, it is far more efficient for all of us to specialize.
Yeah, right.
And not be generalist. Okay, we even have them take specialized fundamentals of engineering exams. We have you take specialized PE exams, which are good things. But the more you're thinking about your particular field, the less that you're thinking about the overall system and the overall problem.
Right.
And these are very, very big questions.
No, we can. I think specializing is still okay as long as the ability to work together is there, right? And the ability to listen to each other across different disciplines is there. And I think that's one of the key things that we emphasize in our degree program here. And
Yeah.
just like Connie, right?
Connie does. Our capstone does.
Yeah.
Right? Except you opt out of that. See what I did there? right? I mean, yeah.
The
The rest of us do it all together as a joint accounting, except environmental.
But yeah, so
Right.
yeah,
It's
the
hard,
relevance
but no,
isn't really
it would
there.
be, it would be it would be very, very, very difficult to take environmental and plug it into our design build capstone as an emphasis, and then you get the whole problem of like, well, numbers. What if we don't have enough teams? And
Right.
I mean, it's very tough to teach a comprehensive class, a multidiscipline, class.
Yep. Now, that might be a great segue to
Yes.
their,
Segue to.
to their recent experience at the work
Oh
environmental
yeah,
design
let's
contest.
talk. Yeah, let's talk about that. So you just brought a whole bunch of students
Yep.
as part of the class,
Yep.
right? Which class was this part?
So EMV 4270. I'm still
Okay.
not used to the 4-digit.
Oh, I'm not.
So,
This
yeah.
is so dumb. Okay, hold on a second. The whole 4-digit thing, because I hate it. I never. I refuse. Actually, if you look at my.
Okay, 427. Sorry.
Yeah, exactly. Thank you. Talk about in real terms. It's so funny to me. Yeah, go ahead.
Oh, I still say like I'll say CE 160 like when I'm
Exactly. As well
like
you
when I'm
should.
TAing,
Yes.
and then all the students are like, "What?"
What?
I'm like, "Oh, 1600. Sorry."
Right. This is the dumbest thing. The whole reason we added this zero is for workday.
Workday, yeah.
Workday. Serious? I mean, we are the school that invented computers. And even after 100 and some odd years of calling classes by a 3-number sequence, Workday comes along and we're like, oh, well, we'll just change ourselves to match Workday. This is like the precursor to like Judgment Day on Terminator. When the computers are actually running things and then they try to kill us. That's the next step. Okay, my prediction: Workday will try to kill us before the end of the.
Bring back Access Plus.
Bring back
There
Access
was nothing
Plus.
wrong with it.
There wasn't anything wrong with it.
I liked it.
I like this guy. I like this guy. Right?
Yeah.
He's probably got a flip phone in his pocket.
But
Right.
the poor freshmen, they're so confused when we're like.
Oh, I know.
160.
it.
Wait, hold on. 60. What? We're so confused. But anyway, so 427 Environmental Engineering Systems is
Okay.
the course, and I teach a two course sequence in their senior year. So we actually worked on it for both
Okay.
courses. So they went to New Mexico State University puts on this work environmental design contest every year. I didn't know about it until last year. So which is
Oh,
why
yeah?
this is our first time trying it. They have industry and government people that provide them with tasks and problem statements.
Which makes perfect sense to have this in New Mexico.
Yep.
Right? Students,
Lots
you know
of-
why?
Is it because they did a lot of like nuclear testing down there?
No, it has nothing to do with nuclear testing. It has nothing to do with nuclear testing. Ladies, why would this make sense in New Mexico?
They have a lot of environmental issues that
Oh, they do.
would
Well-
like to see other students try to solve for them.
Well, they are one of the 4 states that have this water sharing agreement from Lake Powell. And they are currently, all of those states are currently trying to struggle with how do we, if we've got to, see, once Lake Powell reaches these levels, the amount of water that each state gets is decreased through this agreement that goes all the way back to like the early 1900s. And they made this agreement when nobody ever thought such a thing would ever have to be used. So now when they hit these levels at Lake Powell, they're like, okay, you're getting this many fewer millions of acre feet of water per year. It's a problem. It's a problem because we have to split between those states and Mexico. There's an agreement with Mexico, and it's a deal. It's a deal. So anyway, the point is they got a front row seat to the water shortage crisis, and so it makes perfect sense.
Among
for,
other things, they
Well,
have
they have other-
a slew of environmental problems. So
Yeah.
so they
yeah, because we did used to drop bombs there.
yeah, it is relevant.
Yeah, it's relevant.
So they come up with these tasks, and basically we opt in to some of these tasks. So I brought 20 students, 20 seniors with me. We formed 3 teams.
Here, hold on a second.
Yep.
All right. Sorry about that. All right, let's go to. Okay, the connection is not. There it is. There it is.
There we go.
All right. So there on the right, we got
Yep.
the 20 students.
20 students with myself and Lauren Schwab, who is our associate teaching professor here. So we went to New Mexico and competed. So what this environmental design contest does is, because of these real world tasks, or to do these tasks, students are, of course, asked to write a report and do presentations, but also give a bench scale demonstration of their solution, their engineering solution.
Aha. So is this a picture of said?
Yes, so
Whatever.
those are some of the bench scale demonstrations we did at on site, I suppose. So they designed it. They made sure the numbers actually what they say in the report are true. So percent removal, how much they cleaned, and all that. But in addition to that, they had to do some pretty serious techno-economic analysis of their solution.
Ooh, really?
Yep, and
Really?
then do actually have a business plan for how would you pitch this
Ah.
to someone who might want to either buy that solution or hire you as an engineer to take this on. So that was
Ooh,
kind of
that's kind of interesting. I didn't realize there was a economic side to that.
Yeah, so they
That's kinda
actually had
cool.
to do a business pitch as well.
Oh
So
yeah.
that was a very interesting
The
experience.
business pitch is you can build this and pay for it, and the people will pay for it in taxes.
No, so
Oh.
some of them were more public sector type, right? So
Yeah.
this is the solution.
Yeah.
This is how much it would cost the government to do it.
Right.
But some were actually, hey, this is a company. We have this solution. Would you buy it? More of that.
Have you heard of Phoenix's net zero water program?
I have. Yeah.
Yes.
But
I just heard about this actually this last week, and I did this as current events in my class. The short version is that if you're building a project in Phoenix and you need a building permit for it, and it is fairly water intensive, you have to bring your own water to the permit. I'm paraphrasing a whole bunch of stuff.
Right. But in essence, that's what it is.
So those designs that you're talking about could be necessary from not a public but a private.
Right.
A private company would
And
be
I
like,
think-
man, we can't get a permit to build our project unless we figure out a way to provide enough water for it. So we got to clean our own on site.
And I think
it's kind of crazy thoughts.
the private part is actually growing the need for it.
Well, that's
So,
what Phoenix
yeah.
is doing
Right.
through this net zero water initiative.
Right.
They're like, you know what? Why does the city have to think of all the solutions? They're literally like, you want to build here? You come up with a solution, which is a different way of thinking about it. I mean,
Yeah.
because such a thing would not be done here now.
Right,
I've
absolutely not.
never, as an engineer, I've never been asked for such things. Rarely even been asked to think about conserving water, to be honest.
Right. I do think things are changing a little bit here too. But so
Yeah, sure. I mean,
these three students were the team leads of the three
Aha.
task teams that we sent to New Mexico. So
ooh, you want to tell me about your problem statement then? Here, we'll have you start. And
Yes, we were task 1. I guess they were all just given a task number, but my group focused on post-wildfire flood mitigation in watersheds.
ooh, okay.
So
Very that western
yeah.
part of the United
So-
States. Very
So post-wildfire, like all the burns, like all the organic matter that gets burned creates a hydrophobic layer in the soil. So water just
runs right off.
runs right off.
Yep.
And
Yep.
I think the CN value increases. I think like your CN is like plus 25.
I have no idea what that means, brother. CN of
Curve number.
Okay.
It's pretty much similar to like asphalt.
Oh,
It just runs right off.
Oh,
There's
so it'd be
little
very similar
infiltration.
to a hard surface, which does not help if it was already dry,
No, it does not.
right? And that would create flash floods and other problems
Yep.
and landslides. California. Okay, so what was your solution to this?
We focused on log check dams and then polyacrylamide application.
Help me again.
So polyacrylamide is this anionic polymer where if you apply it, it helps to how do I explain this? Retain water in essence.
Is this like a treatment that you'd spray on the ground?
Yes. So there's two different versions of it. There's like a hydro mulching version where you can spray it like a liquid. We focused on the granular version.
Okay.
Where it's like a broadcast spreader, like how you like fertilize your lawn.
Okay. Question that just jumps out at me. You ever been in like the Colorado mountains after like a year after a wildfire?
It's pretty desolate. I've been in
Well,
the
it
New
is,
Mexico
but
mountains.
what's that?
I've been in New Mexico hiking after wildfire.
Okay, then you know what I'm talking about. These are remote areas.
Yep.
They're not easily accessed by a
No, they're not.
broadcast spreader.
Mm-mm.
How do you do it then?
That's so. I guess
You're
the
like,
area-
oh, that's some other engineer's problem. All right, we got the.
Part of their problem.
Oh, oh,
That
it was. Oh, that was part
one
of your
the
problem.
problems that the judges fixated on, where like the area we focused on was next to a town, so it has infrastructure there, like roads and other like little like dirt roads like in the watershed that they could, but that's the problem they focus on, like in like these big remote areas. How are you going to get
How do you
equipment
get
there? And money, like that's just it's going to cost more to mobilize.
right?
Maybe you have to switch equipment and not use a broadcast spreader.
So what was your answer? Oh, you're like
More research needs to be done on it. That's where
oh,
I
the
did
answer
see-
is more research.
I did
okay.
see this really cool thing where
Yeah.
I think it was on like Instagram. They have these dogs and they like strap pouches to them, and like post wildfire, like they'll like have them run and like it'll like drop seeds to like help regrow native plants.
Oh, okay.
I didn't
Okay.
I didn't propose that idea, but I
didn't
saw
propose.
that and I was like, that's kind of cool.
That you didn't propose, right? Oh, what you need is a whole bunch of those.
So like 20 dogs and then
20 dogs.
have 'em
Just
run.
let them run loose. Okay. All right. Interesting proposal. Okay. All right. So tell me about your problem statements. Or I'm sorry. How'd you do? Did you guys win?
We got first place in our bench scale design and then second place overall in the task.
Tell him about the bin scale.
Oh yeah, the bench scale was in one of those photos.
Okay.
There. But
Oh,
we,
here, I can bring it back. Here, which photo is
perfect.
yours?
Hold
on a second.
we're in
I'm
the
sorry.
red polos.
You're wearing the red polos? Okay. Sorry, for some reason, it's not linking up on this. There we go. There we go.
There it is. So
All right.
on the left there, so like in the kiddie pool is our bench scale demo. So that's a section of the watershed. And then
Okay.
on the table itself is our entire watershed, and we 3D printed this.
Oh, that's okay.
So that's a 1 to 6,000 scale of our watershed of interest.
Okay.
And then the one on the table is just kind of like it's there for looks. It's
Okay.
it's to look pretty and fixate and show like the places where we're applying all the log check dams and the polyacrylamide.
Okay.
So like we highlighted those areas on that big
Hold
scale.
on. What is a log check dam?
It's just a bunch of the dead logs
Yeah.
assembled in a dam. Like
Oh, okay.
fashion,
Yes.
like,
Yeah.
like, just
All right.
like
All right.
like vertical, like piling them into the ground
Okay.
to
Okay.
stop flow.
All right.
But yeah, so then the smaller version in the kiddie pool, we applied, or they supplied post-wildfire soil
Mm-hmm.
that we could apply on there. And then we implemented scaled down log check dams and then also applied polyacrylamide to kind of represent our solution on a smaller scale.
Okay. So your demonstrator was top of the competition, but you got second place overall. Why'd you get second?
I still don't know.
Still don't know.
So
Okay.
it's-
All right.
I think there's some
Right.
some behind the scenes.
Like University of Nevada, Reno didn't win it, did they? Or
Listen,
something like that?
no, not
Oh,
necessarily. I will
Okay.
say, so if you look at their historical winners,
Yes.
the same university team does not, almost never wins both first places. So
Oh,
I think there's that, and
okay.
some of the judging numbers we saw were questionable.
Oh, the fix is in. Oh
Yeah.
no.
So
All right.
it's because Cal Poly. Oh, I shouldn't say names maybe. But
Oh,
I'll name
Cal
drop
Poly.
them.
All right.
If they want the smoke, they can call me up.
Okay.
You can put my number in the.
Okay, I'll
in the
put. All
footnotes of
right. Footnotes. All right.
But like Cal Poly had two teams there.
yeah.
One of their teams got second in bench scale. We got first, and the other Cal Poly team got first overall. So I'm like, how do you?
Wait a minute. That doesn't make any sense.
Because the bench scale points like attribute to your total score. So that's where I'm like, how did you make up so many points?
when you
know,
didn't even get first or second on that scale model.
But you
one.
know, I'm not a judge,
Oh,
so
well, I know. I know.
what do I know?
I understand. I understand. All right. All right. So your contention is you were robbed. Okay.
Yes.
Okay. All right. How about yours? How about you both led different teams?
Yes.
Okay. You want to tell me about yours?
Yeah, so we were task 3, and we were looking at bioremediation using fungi. So there are a lot of abandoned mines across the United States.
Oh my gosh, yeah. That's
And
one of our like. Okay, so it's been a little bit since we've done it, but one are you at all familiar with like the mountains would be south of Denver and kind of to the west of the major north-south interstate that cuts through Colorado, like going towards the Four Corners area, like Ouray, Colorado, and no, you guys are looking at me like you have no idea what I'm talking about. All right, but go ahead. Hold on a second. Okay, hold on a second. All right, so tell me about your project, and then I'll get some pictures here. Go ahead.
So yeah, there are a lot of abandoned mines across the United States, and the company that was sponsoring our task, they found that there's a very big environmental issue where if water runs through these abandoned mines, they pick up a ton of heavy metals, and the water that runs through the mines eventually ends up in a stream. So they wanted us to come up with a way to see if we could leach out those heavy metals by the mine and clean the water before it gets to those rivers, specifically using fungi.
Oh, okay.
Passively, yes, because they are in abandoned areas. It's not really easy to
No.
provide operation and maintenance for a solution.
If you go in Colorado, you go off-roading, like take Jeeps and stuff, going like, there's a whole abandoned ghost towns here. This is like one of our favorite spots. Ouray, Colorado. I have pictures of our family right beside that old mine. That's an old silver mine. Silverton, Colorado. I mean, hold on a second. Let me see. There are abandoned mines just everywhere out there, and it's just fascinating to go drive around them. Like I said, yeah, we've got a picture right beside, like standing right here. This structure is absolutely monstrous. At one point, that area, the Ouray, Colorado, Silverton, Colorado, produced a huge chunk of the world's silver. But anyway, yeah, this is a quite the serious problem out west. Okay,
Yes.
and you're doing this with fungus.
Yes, so the
All right, tell me how that works.
The metals we
How
were
do fungus
interested-
eat metal?
So they don't.
Okay.
The metals we were interested in were zinc, copper, and manganese, and the fungi that we chose, they adsorb the metal. Yeah. So as the fungi grow, the metals that they come into contact with will stick to them.
See this? This happened while we were out there, actually. We didn't see it, but it was that same year. One of the foolish part of it is I think the EPA might have even caused this. Like there was a dam at one of the heavy metal mines holding back a whole bunch of toxic stuff, and for some reason that dam broke. I don't know whether it was an accident or incompetence or exactly what it was, but it turned this whole river orange. I mean, not a small river. This was in its day. This is quite the. Now, these might be pictures of multiple different incidents in multiple areas, but what you're talking about is a sudden release of these heavy metals and the effect that they have on what would normally be. I mean, could you imagine kayaking down this river? I don't know. I think I'm skipping kayaking that day. But the point is that I mean, there's these abandoned mines everywhere in the mountains of Colorado, and yes, it is an interesting question that I don't think has a good solution to yet.
Yes.
So what'd you come up with?
So we came up with using a wood chip bioreactor, which there's a lot of research being done here at Iowa State using them specifically to take out nitrate from water.
But aren't those separate issues?
Yes.
Nitrates in water is our whole fertilizer problem.
Yeah, but so wood chip bioreactors are used for that, but
Right.
they
They're
put that
saying what if
idea-
we take that idea
And they actually
instead
did
of
it and showed.
nitrogen,
Yeah.
we
Yes.
show that we can do it with the metals you were talking about.
Yes. So
Okay.
they because we use wood chips in
Yeah.
them, we inoculated the wood chips with the fungi we chose, and the wood chips would give them a continuous food source, so
Okay.
they could continue to grow. In our bench scale, we had
Okay.
contained them in a drain tile pipe, and then
Okay, so what? Then the fungus grab the metals?
yes,
It just sticks to them?
yes,
c-
depending on
'cause
the
they don't eat 'em.
retention time. No,
Okay, all right. So the fungus grows on the wood chips.
yes,
We run the polluted water through the wood chips,
yes,
and then the fungus grabs said chemicals that we would want to dispose of.
correct.
And then the effluent is then free of the heavy metals, or at least greatly reduced, or
Greatly reduced.
greatly
not
reduced.
free.
Okay, all right. But to do so on a river of that size, we're talking about a fairly large amount of wood chips
Yes,
and fungus.
yes,
And we're certain that this is not how the zombie virus starts, right? These new fungus getting heavy metals on them. I mean, this sounds like a bad movie, doesn't it?
that was not within the scope.
That was not within the scope of the problem. See, you're focusing, right? This is well-intentioned engineers are going to cause the demise of society. Although my money is on AI doing it way before you guys start the zombie virus. But go
So
ahead.
maybe it's the zombie fungus in the workday apocalypse that.
Oh,
next.
the zombie. You know what? I'll take my chances with the zombies before workday. All right. Okay. Well, that interesting. Okay. So how did you guys do? Did you win?
Yes, we won the Innovation for Sustainability Award
Okay.
across like the whole competition.
Oh, cool.
And then we got first place with our bench scale design, and
Right.
then second place overall.
So, see,
What the
again,
heck?
again.
Again. You get the first
And-
on the model, but yet they're like,
This is-
no, not good enough.
This is after the judges were basically gushing over them the
Yeah?
whole time.
Well, it is kind of a cool idea. We're using wood chips.
So one of the
wood
things,
chips and
Yeah.
viruses to grab heavy metals and
not viruses, fungi. Very different.
I'm sorry,
come on.
viruses. Fine.
Don't make it a zombie virus thing, okay?
All right.
But
I'm sorry, I had the virus thing.
I will say though, it was really interesting looking at the rest of the competing teams.
Yeah.
They were from like 13 other universities,
Yeah.
and a good number of them. A lot of them, tried too hard to make it innovative, and so for task 3, for example, they didn't really make it truly passive, or they didn't really think, they are building concrete structures that will, last for a very long time past the
Yeah.
the time that these mining
Create its own
Yeah.
problem.
Right.
So,
Okay. Whereas
All right.
our team's focused on much more
Something
simple.
actually usable and simple.
Yeah, simple. Ideas, but put
Good
it together.
engineering. Well,
Exactly. The
good
elegance.
engineering is at its heart usually basically simple.
Exactly, and that's really the thing that I was
Okay.
trying to drive home to them, and they
Aha.
did so well with that.
So you're saying you were well coached? Is that what Kairu's kind of getting around at? Right?
No, it's not
Well
about
coached.
me. No,
Okay. All right.
But I was like, that's one thing that all the teams did so well.
Okay.
Really didn't
Practical engineering that could
Right.
be useful.
Right. That is
I like
cost
that.
effective, practical, but also like it makes sense in an
Well,
elegant way.
Engineering solutions that nobody can afford don't do any good.
Exactly. But a bunch
You
of
know?
the competing teams had those. And
Oh yeah. Yeah.
okay,
Yeah. Yeah.
no.
Well, it's easy to do engineering when there's no budget.
Yeah,
You know.
Oh, we'll just spend millions of dollars on this one thing.
Exactly.
Okay, all right.
Exactly. All right. So next. Wait, hold on. How do you get the innovation award for the entire conference over multiple disciplines and still not even win your class? That's weird. Okay, go ahead. I'm sorry. Go ahead.
So I was the team lead of Task 5, and our task was to recover constituents from produced water from oil and gas production. So like when you pump out the oil and gas, it's kind of in water, and then you separate the oil.
Well, yeah, you're talking about using fracking to force.
Yeah.
Yep.
Yep.
Oh, yeah.
Yep. Sorry, some people don't know what produced water is.
Well, no. I get it because fracking has drastically affected my particular industry. we went from natural gas prices, say, at this level, and then fracking comes along and natural gas prices drop to here. And then it's like, oh, we don't like fracking anymore. Natural gas prices back up to here. And then it's like, oh, yeah, we actually do. And so it's created a very volatile energy market.
Okay.
Okay, so go ahead. So we got all this water from fracking.
Yeah.
It's got oil in it.
Yeah.
We don't want that.
So,
Why not just let it sit there and settle out? Wouldn't it naturally settle out? Or are we not that patient?
So they actually remove the oil from the water, and then the water is like the resultant that you don't want typically.
Oh, so the water's kind of nasty afterwards.
Yeah, so it has very high concentration of total dissolved solids and salts and a lot
you just
of
pumped it through a whole bunch of rocks.
Exactly.
Makes
so
sense.
like there's a lot of really valuable stuff in there, like including lithium, magnesium, strontium, a lot of critical minerals.
That we need for other things.
Yeah, so our project was to
Are you
try to
saying
recover
fracking
those.
as a byproduct could have lithium?
Yeah, not
Oh, that's good.
in what we were looking at. It didn't have a super high concentration of lithium.
Mm-hmm.
So we decided to try to recover magnesium, actually.
Okay.
And then we had a 3-step process using reverse osmosis, adsorption, desorption, and chemical precipitation.
This still does not sound cheap.
No.
Okay, keep going. I'm sorry.
Yeah, especially with like the high pressure that you need to force that high TDS solution through reverse osmosis.
Right.
But yeah.
Once again, there's no way to clean water except by using a bunch of energy.
Right. Yeah. And we didn't win anything, but it was still a good experience.
All right. Well, what is the benefit of such experiences? So this was like bonus for the class here, right, Kaoru?
No, it was a required.
Oh, it was
part.
required.
Yeah.
Okay.
Yeah.
Okay. So
this was like their thing for the whole semester.
the whole thing.
We did a little bit after because this was early April, but this was.
So are these topics, are these things that you are currently doing research on?
No, not at all.
Oh, okay.
So I actually like to do random things like this.
Yeah.
Not random, but a lot of the principles that we teach are
Right.
applied in all these. So
I could see where they would be.
I can apply it and help them.
Okay.
But they also had to go out and get help from other
Right.
professors and other practitioners.
Oh, I can definitely see that. There's
So
a
they
whole
had to get
host of
auditors and all
subjects
those.
and all
Yeah,
these.
right.
Okay. All right. That's cool stuff. That's cool stuff. So part of the class, you had to do it for a grade.
Yep.
Okay. All right. And then how does any of this directly relate to any of the jobs that any of the three of you have taken after school, or is this more like, it's just good to know?
Not necessarily the topics, but just the skills you learn from working with a brand new group of people, learning their different communication styles, work ethics, and learning, like, especially as a team lead, learning like everyone's strengths and then helping them do a portion of the project where they'll be interested and like really, really shine. I thought that like that component of it was the most valuable thing. I took out.
All right. How about the other two? What do you think was the takeaways from this? Go ahead.
I'll second what Hally said. Being like the team lead and kind of acting as like the project manager for this project for 2 semesters, it kind of gave what's the word I'm looking for? It gave me like a good overview of like the entire project.
Real world leadership experience.
Yeah, exactly. Okay. And yeah, I mean, for my project, it's actually pretty useful for what I'm going to be doing because I'm going into water resources design. So that's a lot of like watershed analysis and looking at like wetlands and kind of, I guess wetlands are the main thing I'll be focusing on. But
okay. All right, Caitlin, what did you think?
I don't think that what my task will apply to what I'm going to be doing after I graduate. But like Hally and Jack said, those soft skills that we've learned as team leads throughout that whole project are very valuable, and they were kind of on like a times 10 what was expected of us at school because we went to a national competition. The environment was a little more
Are you saying
intense,
there's more to learn in engineering than just engineering?
Yes.
What a crazy idea. I wonder if anybody else knows about this.
So the other thing is that they had to defend their solution in front of judges that
Oh,
were basically
yes.
mostly engineers,
Yeah.
and basically go through a bidding process, but
I like it.
a little bit
Yeah.
more, probably a little bit more.
See, that is one thing
Pressure.
that's one thing that I make capstone students for. I'm one of the technical advisors for
Right.
the design build capstone, and I think I'm the only technical advisor that makes them come into my office and do a defense.
They should all do that.
You're preaching to the choir, girl.
But see,
okay.
so I,
Alright.
I dare say that
You dare say
that
yes?
this experience is better than the C and Connie capstone.
Whoa, you're
because-
talking smack now.
No,
Listen to this girl. Yeah.
Because they had to defend their solution to people they did not know until the moment they walked into that room.
Oh, I think I would challenge you. Ask the seniors that had to do mechanical. They probably would have preferred that. Right, because I know,
So there's that
knowing
side,
me.
right? But they had to do the whole introduce themselves,
Yeah.
shake hands, and then in this room, just 6 people, 6 judges staring at them.
Yeah,
Go through this process.
putting
and,
you on the spot.
yeah, answer all
Yeah.
those questions, and with very little support. Right? I was there, but I couldn't say anything. So one of the requirements for the faculty advisor
Yeah.
is that we bring them there. We don't do anything when we're there.
Aha.
We get them the supplies.
Sit there and be quiet.
Yeah, be quiet. Provide the support after or before they
Right.
do something, and then drive them around.
And then drive them around. Right.
So that was nerve-wracking for me and Lauren, but we survived. We survived.
Okay. All right. Well, sounds like a good experience. This is definitely an interesting way to do the class. Here, help me out here. What do you think the advantage of? And I have my own suspicions, but I imagine environmental engineering has some of the same advantages by having it be its own major, like construction engineering is. You can do things like this with smaller groups, smaller projects, get to know the students maybe a little bit more, but also do more of this type of thing that gives them a better experience. I mean, do you think that if you were to hazard a guess, would you say that is an advantage of having your own major?
Well, you already know the answer.
Well,
yes,
of course I know the answer. Of course I
absolutely.
ask questions. I already know the answer.
Oh, absolutely. And they knew me from their first year,
Right.
so that they didn't have to figure me out. As
Right.
They figured out the project, and
Yeah.
and they know a lot of the professors. They felt comfortable going to them to ask for help and all
ask for
that.
help.
And
Sure.
so that's part of it. And then the fact that you can do this, yes, in a smaller class, and still actually envision doing this for years
Yeah.
is just
Are you going to be able to do that? Because you got a pretty popular major. What if the numbers keep going up? And
we'll have to think about that. But
Okay.
we just need a lot of donors to give us money.
we need a lot of donors to give us money. Well,
to
hopefully
travel.
so one of them comes up with a way to make clean water for a fraction of the energy currently. They patent it and they get uber rich. They come back and knock down town engineering and put their name on a new building.
I don't
Sound good for you guys?
Or
Who's up for
before you do the building,
that? What? No, we're knocking it down. I mean, if they what? Oh, listen to her.
fund-
Before you do the building,
Fund
old
the
Kaoru
next
could
year's.
use a little research money.
No. I want
Oh.
to send more students to this environmental design contest.
You know,
So give us money.
we do the same thing for in mechanical. We have our own student org, not as a class because it's not a separate class. But we have a student org. They do have a national competition. I'm not really big at participating in it because our students have plenty of group projects already.
Yeah.
I mean, and they're pretty brutal time-wise, and so I want them focusing on the stuff. But the national convention that I take students to, we do a student one in the fall that's more like a huge nationwide career fair, really. And then we do the major convention in the spring. There's so much to be learned at those.
Yes,
There's so many more
I mean,
contacts, so many, people that you
before
meeting.
and after. If
Yeah.
you look at the students before and after, they're
Yeah.
changed. Just
No, it's
they
great.
become young professionals just through that experience, from
And
students to young professionals.
I think that those types of experiences do a great job of of developing that professional not reputation, but also professional behaviors and characteristics. And it's like, hey, I'm presenting technical stuff to other technical people in front of technical people that are experts and
that don't know me.
That don't know me
You know,
and-
won't give me an A just because. Right?
yeah,
So-
just because,
so-
right?
And
Yeah,
they're not
just
doing
don't-
it for a grade
Right.
when they're there. So
Right.
it's- Yeah.
Okay.
It's,
Well, I think that's a great experience. Okay, so where do you see environmental engineering, your major going, right? Do you see it like getting bigger? Do you
yeah.
build your own building and move out of town? If you do, take me with you. You know?
I do. So we've actually kind of reached a plateau, I would say.
Oh, you
for
where
now.
you at?
I mean,
for numbers wise?
it's only 5 years in, so
Yeah.
who knows? But I think at a comfortable place where we're getting 30 to 40 students
Yeah.
coming in each year. So that allows us to know them better, but
it does.
and keep our classes relatively small, but still have enough students to do a lot of these fun things.
Okay.
I do think that eventually. And well, I mean, right? Our chair wants it to grow. Eventually,
Well,
it
yeah,
could
because
keep
it's
growing.
making because
Yeah.
you know people are paying tuition for it. So
Yeah. But from my standpoint, it's important to me to be able to keep it at a number where I can get to know each student. And
I would
have
agree.
that,
I
you
think
know,
I think
that
I think it,
experience and that
I
interaction.
think it loses something when you're in class sizes where
Yeah.
nobody knows each other and
Right.
you know
I
you-
never
you
want to
lose.
go there.
Yeah,
Never.
you lose something there. I think that's a fact, right? Yeah, go ahead.
Yeah, I mean, I would agree with that. One of my favorite things about environmental engineering at Iowa State, obviously I haven't done it anywhere else, but
Well,
We're the best.
yeah,
yeah. I just love the connections that I've made with my professors because, like, I've known Dr. Ikuma since freshman year, and especially through work, getting to like interact with you more, it's been a really valuable experience. And I've done research with a few different professors who I've also had for classes, so it's just really cool to know them more personally because I have some friends who are in mechanical and they don't know their professors, and I'm like, I would really miss that if it were bigger.
I've seen that, you know, again and again. Like years ago, I was advising for one of the fraternities, and the fraternity president comes to me, and he's going for grad school, and he's asked me to write him a recommendation, you know, and I'm the chapter advisor, but I don't know him, you know, from an academic perspective. I mean, I know what his GPA is. He had like a 3.9 GPA in mechanical engineering, and I'm like, hey, I'd be happy to write it. Okay, but shouldn't this come from one of your professors in your major? And he said something, you know, I'll never forget this. He's like, yeah, I don't know any of them well enough to ask. You know, and I was like, that is terrible. You know, here he was like president of ASCE, you know, or not ASCE, ASME, you know, Society of Mechanical Engineers. He was president of his fraternity, has a 3.9 GPA. And I'm sitting here going, how do your professors not know who this kid is? You know, he's not just sitting in the back doing the minimum.
And
you know.
like, why are they missing out so much? Yeah, getting to know the students is the best part of our job.
Well, it is. No, oh,
It's like,
God.
what?
Oh, heck yeah.
What are you here
It is.
for?
Yeah, see,
I don't get it.
because that's all I'm here for. You know, I'm unlike Doctor here. You know, I don't do research. I don't publish. I don't do research. I'm a teaching professor, so all I do is teach. You know, if I didn't enjoy that part of it, you're right. I wouldn't be here. Why be
Honestly,
here? I'd be back in industry doing
If
something.
I had to choose between teaching and research, I'd choose teaching every single day. So
Yeah. Well, that's why you're a freak in your potential in your
But
particular area.
why be at a university setting if you don't want to teach and get to know the students and make those connections and help them and see them grow? I don't get it.
I
don't
have
get it.
always wondered this, but I'm going to go out on a limb and say I think there's a couple people that don't enjoy teaching at Iowa State.
I think it's more than a couple.
The students are looking at, okay, what you can't see on the camera is the looks I'm getting from the students. They're like a couple, you know, they're about ready to, okay, go ahead. You look like you have something to say. I don't know.
Yeah, that's what like Hally said, we've been so fortunate to get to know our professors, and that's also a testament to our professors in our department wanting to get to know the students and build that relationship, whereas I think we've been really fortunate that we've had professors like that, where I have seen my friends in other engineering disciplines here where, yeah, that's the case, where they don't know their professor.
Oh, yeah.
Well enough
and it
to go
is
up to
sad,
them.
isn't it?
Yeah.
You know, for one of the years ago, one of our female students at her sorority, they had a professor appreciation night, a dinner, and I was her invitee, so I'm like, sure, yeah. She's like, hey, we got this appreciation dinner. Would you just come to the sorority? It's only for like a couple hours. You just come, you eat, you talk. I'm like, yeah, sure, yeah, I'll go. And back then, this was when Connie, we were still doing advising. We don't anymore, but we used to. Used to be. Do you do this, or do you have everyone go to the advising center Advising center? Okay, all right. Here, don't forget use it. All right, but anyway, so back then I was her advisor and I was her Connie 222 instructor at the time, and we're sitting there and we're sitting next to, I think another girl from the sorority who, she was either Emmy or Aggie or something. I don't remember the major. It doesn't really matter. The point was, so she introduced me. And she's like, hey, he's my instructor and he's my advisor and, and this and that. And the girl next to her was like, wait a minute. Your advisor? She's like, yes. And he teaches you a class. And she's like, well, yeah, that's what they all do in construction. She's like, she was ticked. She was like, my advisor wouldn't know who I was if they ran over me in their car. I don't know any of my professors well enough to show up tonight. None of them showed tonight. I mean, she was like upset, like she was getting the kind of the short shrift on her degree. And I don't ever want to get so big that we miss that in our areas. But all right, go ahead.
I think that's the big part of environmental. I mean, I've had my roommates and my friends be like, "Oh man, like I like hate this professor and this professor," and like they
hate
don't,
this professor.
and it's like they're terrible at communication. And I don't think I can say that for any of my professors here. Like
any of them?
No.
Oh come on! No, come on!
Call me a suck up.
Yeah, you are. You totally are.
Brown noser, but
yeah, I don't even. Yeah, it's like you don't have to like everybody, but
yeah, but like it's not. I mean, there's some teaching styles I'm like maybe I don't thrive in like that scenario.
Yeah.
But it's not to the point where I'm like, oh, they're like just the worst. I mean, like I played tennis with Dr. Ellis a few times.
Did
I'm
you?
like,
yeah.
Like, even and like Dr. Charbonnet, like every time I see him, it's like, hey, what's up? How you doing?
Yeah.
It's not just like head down.
Yeah.
Walk past each.
No, I get it. All right. Well, that is a good thing about the small touch and the small. So last thing here. What's the job market like for your environmental engineers? Everybody got jobs? Everybody, like all your classmates? Is it really, what's the recruiting like? What's your potential in the marketplace like, I guess, is what I would ask.
From what I've seen, is a lot of growth opportunity, like a lot of job security, because we're never getting rid of wastewater treatment plants, and we're going to keep building them and keep maintaining them. So that part's never going away.
Job security, that's true, right? People got to drink water, and then people got to get rid of it. That's a fact. Go ahead. No, you were about to say something.
Yeah. Well, my job search was a little unique because I was looking specifically in Chicago.
Mm-hmm.
And there was not a lot of need for entry-level environmental in the Chicago area, so I struggled a little bit, but that was just because it was one location. Like,
because you're like, I gotta have this location.
Yeah, if my search was broadened, it would have been a lot quicker, I think.
So does everybody have jobs at graduation? Because that's the way it is in Connie. I mean, we've had this highest placement rate in the College of Engineering for the last several years.
Right,
so.
probably not as high as Connie, but very close.
Very close?
Very close.
Well, that's good.
And several are either going into or thinking about grad school as well for a master's.
Okay,
So.
all right. Right, what, you'd be stuck with her longer?
Not with me. I usually say go somewhere else, but
Go
if you're
somewhere
going to
else.
stay here, I'd love to have you.
Yeah, no, we should have more. No, I'm a firm believer that now I don't get involved with our graduate students hardly at all, but I'm a firm believer that we should be recruiting more grad students from our own product.
Oh, yeah. Especially when we get great students. Right?
Yeah, that's right. We know them way...
Not to suck up to you guys, but I think we have great students. Oh, my goodness.
Well, and you know them by this point.
I talk to, colleagues across other universities, and I'm like, I don't have that problem.
Yeah. Well, all right.
And
No,
I've
I've always believed this, is that we should be recruiting more.
But for that you need the relationship to have been built, right?
Well,
To be able to say, hey, why not grad school?
Yeah, think about
But,
grad school.
Yeah, if I say it to students that I know well versus someone, if the professor doesn't even know them and they already have a job offer, which one is it?
Yeah,
they're going to
that's-
pick the job offer
Well,
unless
totally.
you can really talk to them early and
Yeah.
encourage them.
True. All right. Well, it's good. I'm glad to hear that, all you guys have jobs, that you got, your path lined up. You seem very focused all the way through environmental. So that's awesome. Let's see here. So I don't know, did you have any last thoughts on your unique major here in the small corner of engineering that is town engineering? Anybody? No?
I'll plug it.
Yeah, okay.
Hey,
Yeah, you're a
do
graduating senior. I
environmental.
mean, you can say anything you want. Hey, there's no filter here. If you're like, yeah, this was a terrible idea, right? But maybe it was a good idea. You plug it. You say, yeah, people should think about
I
this.
think so. If you want a major that'll focus on real world problems that are not going away
Yeah.
anytime soon
No.
or ever for that matter, and you want professors that actually care about you and want to get to know you,
Yeah.
it's the perfect spot, honestly.
All right. That's pretty
And
big
it's probably
endorsement.
better than Iowa's.
Oh no, it's
program, so-
100%. You don't have to say probable. Okay, it's definitely better. Definitely better. All right.
Honestly, I agree with that.
Okay.
Yeah,
Alright.
it's been a great experience, and I didn't switch out of it. So that says
That's a
something.
big testimony. That is, because goodness knows you could. I mean, there's tons of other majors and lots of people hiring. So you could have.
Yeah.
True. All right, Caitlin.
Yeah, I agree with what they both said, but I also want to touch on that my other peers, I've gotten some really great friends out of the environmental engineering major because it's so small for right now.
Yeah.
Hopefully it will continue to grow, but right now there's only 11 of us graduating, so we all know each other and we're all friends and we all talk in and outside of class.
Okay. Awesome.
Even with our current juniors and sophomores, 30 plus students, we see the same kind of dynamic.
That's
So,
good.
Yeah,
That's good.
we love seeing that.
Right.
And we do a lot of hands-on stuff and project-based learning
So,
and all that.
are you guys
the
like
good
our?
stuff?
Are you guys like our? Well, one, I would suggest you guys start a student org.
We have.
Oh, you do have one?
Yeah,
Oh, okay.
water
Okay.
professionals. yeah.
Okay. All right. So, like our Connie students, they have the Connie bar crawl. I don't know if you no, never mind. You guys don't need to start that part of, Caitlin's like, wait a minute. Caitlin started it. I see that. Go ahead.
No, we just weren't on their mug.
Oh, you were there. Okay.
No.
All right, you were part. Okay, that's good. I'm glad to hear you're not being excluded. 'Cause
The mug says the
Civil-
Civic and Connie bar
Civic
crawl.
Connie bar crawl.
And
Okay.
not environmental.
I told.
All right.
I'm gonna call her out. I told Sam Priggy to put environmental on the mug.
Oh,
She didn't
yeah,
do it.
she didn't. Okay, all right. Well, we'll have to work on that. Equal recognition.
Yeah.
All right. Well, I sure appreciate. Yeah.
One last plug.
One last plug. Yes.
This will probably come out later than this, but Caitlin is our student marshal this year for the College of
hey,
Engineering.
For the College of Engineering, congratulations.
Thank you.
That is awesome.
So we get that kind of recognition too.
Oh, very, very nice. All right. Well, that's awesome.
Thank you.
Yeah, okay. Well, congratulations, all of you, for your performance in the competitions. Okay. And on graduating and on landing gainful employment in an area that is decidedly needed. Okay. And with that, I hope if you're listening to this, maybe you learned a thing or two. I know I did, because I was not all that well versed in environmental engineering. So I hope you learned a thing or two along the way. And of course, if you know anyone that needs an engineering major, they should go Connie. But if they don't, environmental.
Second choice should be environmental.
Environmental should
and
be.
come talk to me.
Yes, come talk to her, and there's a great option for you as a student. All right, thank you so much for joining me, and I'm looking forward to seeing another podcast.